guess we can hear you. Hello, welcome to another Ken Seminary series. Dr. Butt, can you mute your speaker for a second because we have echo here. We have Dr. Abbas Butt on the phone today, and he's going to be presenting.
He needs to turn off the computer. Okay, go ahead.
And he's going to be presenting a contract that ERI got from the city of Toledo. Dr. Butt is an alumni from the program here at UIUC. And he's had 40 years of experience. So help me welcome Dr. Butt to the. I'm just gonna call him very quickly to let him know that he can start right away.
Hello.
I have introduced you, so now you can start right away.
Okay. And therefore I can start this one. Thank you very much for joining the Kent Seminar Lecture. My name is Abbas Butt, and the topic of the lecture today is the leveraging TCI data, which is a pavement condition index data, to build a comprehensive pavement management system. An example I'm going to show here the project we have done for the city of Toledo, Ohio. And on this project, the outline of my presentation is the pavement management system concept, the background data what we need for developing the pavement management system, and then what kind of field data collection we made that in the field, data processing, and the challenges that we can encounter in the development and implementation of the pavement management system and the future recommendations. If I look at the concept of pavement management system, that pavement management system, the performance slide, which is we call it the background of the pavement management system. Pavement condition changes with time, and the performance curve is shown on the screen, and the time scale is horizontal. The pavement maintenance and rehabilitation cost is directly related to the condition of the pavement. And the objective of pavement management system is to maintain pavement condition at a condition level at which our maintenance and rehabilitation cost is low. And that is the so-called main theme behind pavement management system. In looking at this approach, we have to evaluate the current pavement condition. We determine the rate of pavement deterioration, project the future pavement condition, and then develop maintenance and rehabilitation needs strategies, and then also then track the performance. I will go into it right here because these are, you might have heard about these important points. in the development and implementation of payment management systems. And therefore, for this project, we developed a so-called the flow diagram that included agro data collection, records review, identifying uniform payment section. But if you look at on this also flow chart, that we have a payment conditions array, and then we have optional tab, which is non-penetrating radar testing, defective testing, and non-defective testing. Those three options were not carried out on this project. And then we did the database development, maintenance and rehabilitation policies, PCI versus payment conditioning act versus maintenance and rehabilitation relationship development of payment condition prediction models, and then the development of maintenance and rehabilitation program for optimization of the budget or for the consequences analysis of limited budget. And then we link with the whole plan with the geographical information system GIS. Now, for City of Toledo payment management system, we have the major and collector streets, which is also known as arterial and collector, and then local streets, which are residential streets. And in our case here, the network is divided, whole city network, into 5 sub-networks. Network 1 is where the pavement arterial streets are maintained by assigned US or state routes, and then arterial streets is also the major street, not assigned with the routes, US or state, and then collector streets, connecting streets, network 3. And network 4 is a local street, and network 5 is also local street, but the maintenance strategies are different. It's like oil and chip and tar roads only. Our main focus was on this project network 4. And funding sources for the bold letters, which is network 1, 2, 3, and 4, are CIP funding, this is capital improvement program source, and then also for the our network 1, 2, and 3, city gas, federal, and state transportation funding also, in addition to the CIP funding. Therefore, it is important how to organize the data, how to organize the database, so that we can do the optimization across networks. And there we can analyze different budget scenarios for different budget for network or collective budget allocation also. Now, looking at the overall city map, city has been divided into so-called 6 council districts also. Council district represents that each council member will be responsible for that district. Therefore, payment management system, one of the decision-making processes, also helps that how the payments are performing within each district. Therefore, we can tag the data and we can analyze the performance of arterial, collector, and residential network within each district also, and see how one district is comparing with the other district. For the little bit background on this project that we have worked on, the network 1, 2, and 3, where the funding comes also from the state and federal funding also. I would say network 1 and 2 is federal, and some of the collector states get also state and federal funding. So the data has been collected in the past by Ohio Department of Transportation. Ohio DOT uses pavement condition rating method, which is PCR, which is different than the AFPM standard for pavement condition rating system. And City of Toledo, then, in partnership with University of Toledo, Ohio, also did pavement rating on the city between them since 1998. And the data that was from PCR as well as with the help of University of Toledo, it was not helping the city in the decision-making process for allocation of the budget and the so-called systematic approach to do the work. And in 2017, city hired ERI to develop a comprehensive pavement management system using micro-cable software, and main focus of our company was network 4, that is residential streets. And then also one of the tasks we had, if we can develop a correlation between the PCR method and the PCI data, that city can utilize the PCR data coming out of the state system. If I look at that, the overall network, city has network 1 is total lane miles is about 274, total number of so-called uniform sections about 1,162, and in terms of square foot area is about 17 million. Network 1 is again the routes which are assigned state route or US route numbers. Network 2 is without the assigned state or US route numbers. That is about 346 lane miles. Network 3 is Collector Street, which is about 200 lane miles. But if you look at the network 4, is the largest lane miles, which is about 1,300 lane miles. And that is the residential streets that contains, that is the maintenance and rehabilitation is it can be reconstruction, it can be asphalt, concrete pavement, those kind of network, while network 5 is residential, but only oil and chip. And those streets are maintained on those bases. In other words, those may be like, we may call it gravel roads also, or oil and chip roads. But network 4 is the largest area, also 81 million square feet. We use our automated pavement data collection vehicle for the data for imaging data collection, which included both the downward images of the pavement as well as the right of way images of the pavement. The vehicle was also equipped with the profiler, therefore we had the profile data available also. And we have also used we integrated with the ground penetrating radar and we collected the GPR data also. And this vehicle had downward images here in the picture shows that we use the latest system. With this system, we can measure the crack that is about 1 millimeter wide driving at highway speed. And the GPR that I am showing is the next image. We were able to, we just collected the data, but we have not processed the data because this was done, this GPR data collection at no cost to the city. We just provided as a value-added option. So the data is there, data is integrated with the imaging data, with the profile data, and with the GPS coordinates. Therefore, we can pinpoint that if there is a need in the past, in the future, to find the pavement thickness information, we have a GPR data available, we can process and identify the pavement thickness. We can identify the uniform pavement section based on the GPR data. We can also look at some forensic type work also. If there is a layer separation or debonding or any voids underneath. Because city of Toledo is having problems with sinkholes. And they wanted to look at that if the GPR data can be used to identify the sinkholes. In our case, we are not collecting along the full width of the pavement, the GPR data. It is a line track option that in the wheel path, we are just collecting the GPR data. Therefore, if the void happens to be under the pavement in the wheel path, and the void happens to be in shallow depth, then we may be able to pick up that one. And in this case, what we did is we knew some known locations in the field where the city found the sinkholes, and we put the cones in that area, and when we were collecting the data, we tagged those points. And then when we bring the data in the office, we process the data, and it was a two-step approach. One is an automated process, or we may call it semi-automated, in terms of that we run the data through the software that detects the cracks. And that process is applicable only to flexible pavements. And then we also collected the information about the presence of the sidewalks curb height available or not, curb height in the field, and a potential location of sinkholes. Now, in terms of pavement analysis, or I should say rehabilitation design, on interstate we will have majority of the state curb and gutter, but for city streets, the curb and gutter information is very important because some locations we cannot change the elevation data, and we have to just do mail and fail. And if the curb height is not available there, or curb height is even available but it is not enough clearance, that we need enough clearance for drainage purposes. So these points are important to look at into the developing maintenance and rehabilitation scenarios for the network level optimization. Then also, we did customization a little bit of the pavement condition rating scale, AFPM E3433. City wanted to use 4 bands of rating 0 to 55 pavement condition index, and then which is the poor to fair condition, and fair is 55, 70, and then good condition is 70 to 85, and excellent pavement condition from 85 to 100. Therefore, we were able to customize and populate the data as per the city's PCI scale, which we call the customized PCI scale. If you look at pavement condition rating, pavement condition, if it's like PCI is excellent condition, which is 86 to 100, and almost left side, the image should look like that. For flexible pavement, I'm showing here, and then good pavement condition minor, like longitudinal cracking, we are showing here in the bottom image. And the maintenance, recommended maintenance and rehabilitation is tied up with the pavement condition. Type of pavement distress is present also. Majority of the time, if they do nothing, if the pavement is in excellent condition, and we just may have to do just preventive maintenance if its pavement is in good condition, PCI in 75 to 85 range, and if the PCI is in fair condition, in other words, 56 to 70, those pavement segments may be candidate for major rehabilitation or preventive maintenance also. But when the PCI falls below 55, pavement is in poor to fair condition, then we have either the resurfacing, mill and resurfacing as or complete reconstruction. Therefore, when we say mill, in the thickness of the overlay will be dependent upon if I have a carbon gutter restriction, can I put mill the thickness and put a roll overlay if I need a structural overlay? Therefore, that will be critical there in that respect. We use the micro paver pavement management software, enter that meter there, and link with the GIS, Geographical Information System. And here I'm going to show you some of the reports we generated from micro paver based on the PCI data. And here we are showing is the pavement area by network. again, I discussed earlier that network 4 is the majority of the pavement correspond to, which is about 82 million square feet of area. And then network 1 and 2, which are major streets, that is the second highest, and then collector street is the third area. We didn't have network 5 in our database because they didn't want us to include that in our network, in our database because of budget, how much money is available for implementation of the pavement management system. Looking at pavement condition, which is we call it the area-weighted pavement condition for network 1, arterial street assigned state route name or the US route number. The PCI is the highest for network 1. Next network is non-assigned arterial street. The PCI for that network was about 53. These PCI values are when we did the pavement condition survey. And then the PCI value for network 4 residential was 39 average for the whole network. If you look at IRI value, and the IRI value again, it is a similar trend that you see in the pavement condition index. The higher the PCI value, lower the IRI value. And that shows with the collector, which are state assigned route number, route or US route number, they get better maintenance, they get more funding, and the performance level is better there for those streets. But these are average IRI values. And the network 4 IRI values, the average is 424. You can imagine that what will be going on at some localized segment level or fraction level. And again, that data is very helpful. Looking at IRI data also and how that affects the performance and what is the significance of the IRI value or the profile also within a given road and how localized variation can be assessed based on the variability in the IRI values. Here we are showing the distribution of the average pavement condition PCI value by asphalt over asphalt concrete pavement, which is yellow. What it is interesting to see the gravel road, so it's only one segment within gravel road. We have only 6 sections, sorry. And PCI value is very high, but I will ignore that. But looking at asphalt over concrete, that was the highest PCI value. And but majority of the number of pavement sections are in asphalt pavement. It is very difficult to identify that which is the asphalt overlay pavement, which is asphalt in city database. Previous construction history data was not available in that respect to document. And therefore, I will go that the aspect of the pavement condition history data also, what we have done that later on. here we are showing is the average pavement condition index by different districts. Again, district, looking at which council district is maybe worst also. Then it can be also interesting is it's possible that there are certain council districts which are being ignored by the city, by Boston. I'm not talking about here the leader. But in some cities, that the upper class neighborhood is getting more money than the other one. Therefore, this tool can identify and show the geographical distribution of the city and the pavement condition variability, and where maybe more money needs to go also in which by council district. Then we did the budget analysis for the whole city, and we looked at that on this graph, if I have a $6 million each year for 20 years analysis, starting 2018 and ending 2038, spending $6 million per year, which is a blue dot line, or $9 million per year, which is orange, and $12 million per year, each year, and which is green. We do not have enough budget available to reverse the rate of deterioration of the pavement at whole network level. And if you look at, again, this one is the budget analysis what we are showing. That budget analysis also includes what if I have $40 million per year and with 5% increase in budget each year, then what will happen? And we are showing is that we can change the rate of deterioration, reverse it, if we have at least that much money available. Then City asked me, okay, what will it cost? Or what will happen if City has only $9 million budget available, flat budget each year, or City increases 5% budget each year, which will be average per year will be $15 million per year, or City increases 10% budget each year above $9 million, which will be average $26 million per year, or City increases $9 million plus 15% increase each year, that over the whole 20 years life will be $47 million per year. And therefore we are showing here that you need at least 10% increase even to reverse the rate of deterioration, which is the green curve. But then if we increase 15%, that is a shortcut change in the reversal of the pavement deterioration. Then we also look at that. What will it cost if we want to maintain the current pavement network PCI value, which is 39? And we found out that it will cost about $37 million per year to maintain that PCI value of 39. And also we looked at that. What if we want to bring the PCI value above the 55 critical PCI value in 20 years? And our analysis says that we need to spend about $63 million per year on average to achieve the PCI value of 65 or 55 in 20 years. And This analysis shows the importance of maintaining the pavement. And pavement is the largest asset of the cities or Department of Transportation. And if we let it go down, then we are losing a big chunk of the assets of the city. And why it is important to maintain it above the critical rate of deterioration. And we display also geographically that what will happen if we are spending 9 million budget, and this is the one how if you look at the red color, the pavement all over the city is red color. It means pavement are in poor to fair condition, spending $9 million per year, and that is the condition as of 2019. And then next is the condition as of 2028. The red is going down, and other colors are picking up. And then here it is in TCI value here, if you look at, will reach 18 average network TCI after 20 years, 29 million. Similarly, if I spend 15% increase, $9 million budget, and that's the network TCI value of 37, in 2019, in 2028, the TCI value will be 28, and then the reversal will happen at the end of 20 years, the TCI value will be 42. We also look at that. If I have $40 million budget per year and 5% increase each year, then how the pavement condition will look like. 2019 TCI is 39, 2028 average will be 40, and 2038 the pavement condition will be 58, which is above the critical rate of deterioration. The city established a target for us that we need to find what is the budget. City needs that one. We also look at that if city wants to maintain 39, then it will cost about $37 million per year to maintain the current TCI value of 39. And then if we have to maintain the TCI value of 55 in 20 years, city will be spending $63 million per year, and that's the TCI value 2019, 28, and then 2038 here. TCI will be 56. Now, I discussed that I will, in the later part, I will go over that challenges that whatever our problems we encounter. And one thing is that overall pavement condition on this network was very bad. I haven't seen that bad overall network level pavement condition. It took quite a bit of time to manually even survey those images that after automated process we do manual surveys. We also found out that there were discrepancies in the different GIS files, and then also the surface types were different there. Based on the historical data that was sitting there, they were pretty bold enough to go back and capture the historical data. And city wanted to have more accuracy in the database. And shape file compatibility and then transferring the data, we have tried macros and convert the data. And I will go over quickly that this is an interesting area where we we'll be working on still on this one because we just signed another contract with the city. That we have finished the previous contract and we are going to do another cycle of pavement conditions survey and looking at and developing the correlation between Ohio DOT PCR value, which is a scale of 0 to 100, while ASTM is also 0 to 100. Ohio DOT uses 14 dispatches for asphalt concrete pavement, while ASTM uses 20. Ohio DOT PCR method uses 12 dispatches for concrete pavement, while ASTM has 90. Therefore, it is saying is there a direct correlation. There is no direct correlation in terms of the depth value and damaging effect of different dispatches. Therefore, we looked at what can we do that different options. We can maybe correlate using some existing correlations between Ohio DOT PCR versus ASTM PCR value, but without any pavement distresses that we can bring that also. Just develop the correlation between PCI versus PCR. But in terms of the development of maintenance and rehabilitation program, it's good to have distresses also with you so that the low PCI value may be due to road-related distress that would require structural rehabilitation treatment versus climatic distresses, and that may be handled using preventive maintenance or slurry seed, those kind of treatments. Then also is that developing the correlation relationship with the distresses but without the field verification method. In other words, develop the new relationship. And we develop the new relationship with field verification also. Therefore, these tasks are ongoing. We are working on that one. Therefore, we suggested the city gave us some of our future improvements, what can be done that one. One thing is that the conducting the polymer cyclometer testing. Second is I think you have been, that is the area where I think you have been maybe more exposed that if we are into pavement analysis and design and how that can be helpful to identify the uniform pavement sections. Diffraction data, which is indicative of the structural response of the pavement. And that can be helpful then in developing the maintenance and rehabilitation strategy at the network level also. And in concrete pavement, load transfer, void analysis can be helpful. And ground penetrating radar, as I indicated, we have collected that. And ground penetrating radar, we can use like different kind of antennas. We can use air coupled antenna in combination with the ground coupled antennas and reaching at different depths. Therefore, we can look at the voice at deeper depths of the sun. And again, GPR, using that one and looking at how the asphalt thickness can vary from one lane to the other lane. Like here I'm showing you data from one of the airport projects we did on the East Coast. And on the airport project, that is along the length of the runway, we show the thickness varies in the crosswise direction significantly. Anywhere from the average 2 inches of AC layer, it goes up to 4 inches. In the keel section, we have 4 inches, we found the asphalt thickness sitting there, while near the outer lane, non-keel section, the thickness was 2 inches also. Then the variability at the cross runway location. We have the asphalt is much thicker there at the cross runway location, and we can even look at how the transition is happening there. And we are able to then develop typical cross section at On this project, we did that at every 50 foot interval, and I think that I discussed with Isaac that we are working at Villard Airport, and we will have another presentation for the students and go over the similar things we are doing that at Villard Airport. And we have interesting findings there also. Underneath we have on this project is concrete pavement. Therefore, cross runway, the concrete pavement is thinner versus the other area. And therefore, I will end my presentation here, and I will open for the question and answer the questions that you have.
I'm gonna try and put the microphone on so we can.
So we can clap again.
Can you hear me?
Yes, now you're muted, but there's some echo here. If we have
Mute the whole thing in the computer. You need to mute him. So we'll click on people. Yes. Mute him. That didn't work.
Yeah, I don't know.
That's on the grid. Want to put questions here?
Maybe we can put them in the chat. Tell him we're.
I think
You can call me by or question answer on my phone, and I can answer them.
Yeah, just turn off the system. Let's make it for. Just
You wanna do that
we
one?
can call him on this one. Turn off the entire system.
Not the phone number that is sitting there on the screen. It will be.
Yeah,
You have my phone number.
Okay, we'll do that.
Should I?
Yeah, just close the GoToMeeting. Yes.
Okay. And then we call only.
Yeah, I'm waiting for all problems. Yes. But did you record the number?
Oh, I
Phone
have.
number.
Let's call on this one.
We have any questions?
Okay, it's 217, yeah. I know his number.
Yeah.
217.
Hear the speaker repeating
Just
the.
look at 217 369 0700. Yes, that's it. He's not answering.
Hello.
Yeah, Dr. Bal, can you hear us?
Yes.
Yeah, first, thank you so much for this presentation. I do have a small question. So, you were showing how you were predicting the future based on the PCI. So, it's the current PCI and the predicted PCI with a certain budget. It will show how the distribution of the road in good, bad, or poor conditions, how they are distributed. But my question for you is a little bit more fundamental about, so the PCI, if you have, if your PCI is your criteria, sometimes you have two PCI, the same PCI for two sections, and the problem is completely different. Sometimes it's coming from the subgrade, sometimes it's coming from the AC material. So how can you be sure about your prediction while just basing your results on a PCI, which is usually something that incorporates all of the distresses and all of the problems?
Now, in the prediction rehabilitation program development, micropaver does use the structural pavement condition also in the development of those budget scenarios, okay? Therefore, you may have the same PCI value for two sections, one that has a load-related distress, will have a higher priority as compared to non-load related distress. Because when we develop the prediction models, we do have the distress data available, and therefore, for distress and the PCI value, they are used together within the micropaver software in the development of budget analysis.
Okay, but
And other software would not be doing that. That depends on how they have written their algorithms for the development of maintenance rehabilitation program. And I think, yes, that is very important point. If it is that some state level, for example, or some other mega data type thing is when they are collecting at network level, they just want to look at is what is the overall PCI or condition index. I should not call it even a PCI value. And then they identify the list of, narrow down the list of segments. And therefore they may be developing the budget for the whole state level or whole city level. And that budget may not be accurate when you are actually going to do that project level analysis. We may call it as a top-down approach, and one is a development of the cost relationship from bottom-up approach, so that if you develop the relationship based on the project level analysis, then take it to the network level, those relationships will be more reliable.
thank you. Any other questions? Yes. Can you please introduce yourself first?
Come closer to
Okay. So thank you for your presentation, Doctor. My name is Zichi. I'm a PhD student here. So I have mainly two questions. Do you hear me?
I'm not able to hear you clearly. Can you come close to the mic or something? Okay.
Thank you for your presentation. So I have two questions. The first one is about the GPR detection of the void underneath the pavement surface that you mentioned. So for this void detection, is that still based on detecting some patterns in the B scan, like looking at the raw data, or have you already figured out some algorithms that can automatically or semi-automatically detect these void patterns?
City has not, we collected the data at no cost to the city, okay? And therefore, city has not given me the green light to go and analyze the data. And if we will be analyzing, we will be analyzing manually. And yes, it is a time consuming. And therefore, if you know algorithm that exists there that can do a good job, you let me know. I think is my experience is it's a very difficult to come up with a reliable solution based on fully automated method. And I am already working on another project in New Jersey area where the data is analyzed by automated methods. But I can tell you that when you're doing project level analysis and using automated methods, that data has to make sense of. And if somebody gives me the PCC thickness 2 inches based on automated method, you know that something is wrong there. And for void analysis, I would rather focus on the manual versus automated. But if I'm not aware of the software that can do a good job, we are looking for a 3D mapping also on another project. And we are putting the multiple antennas at narrow space because we do not have a 3D system, so-called, across the full width of the runway or full width of the road. We have only line scan based, and I can put 4 antennas or 8 antennas, but still it is and then 4 line segments, or 8 tracks, and in between is the interpretation by 3D modeling.
And since you mentioned this software, a follow-up question is, you mentioned this payment management software in your presentation. So does that software serve as a post-processing software, or can it do like data processing during the survey, like real-time data processing?
There are 2 aspects here. That's a very good question. Okay. Now, real-time data processing, what data element we are looking for? Are we looking for profile data? Are we looking for distress data? Are we looking for rutting data? Are we looking for faulting on concrete pavement? Therefore, there are so many elements. Real-time data processing, if somebody says that exists, that in my opinion, to calculate the index, it is not there. Therefore, to do a good job, you have to use both combination. The real-time, I think the latest equipment in the market is LTMS2, is a crack measurement system. You will have reliability in terms of the cracking data, and but that still requires a process. In the field, computer will not be that strong that they can keep up to that one speed at which we are collecting the data. But you can collect it and on the side start processing that also. But then that you will be getting only cracking data, which may be alligator cracking or transverse cracking, longitudinal cracking, or rutting data, or profile data. Okay. But then if you have a potholes or patching or other distresses, that one you have to manually look at that alligator cracking, reliability of the cracking. And therefore that it can be done. Not all AST distresses, but some, that's why we call it semi-automated. Some are processed. In our case, we process all data in post-processing in the office.
Okay, thank you for your answers.
You're welcome.
Other questions? That's it. Thank you so much, Dr. Butt, for your presentation. We are looking forward to your next presentation with us.
Okay.
Yeah.
Thank you very much.
Abbas, I want to talk to you for a minute.
Okay.
So I may call you from my office. I have a visitor who wants to talk to you too.
You can talk to them
Okay.
now.
I can talk to you now. Guys, get out of here. All right. That's a good way to do it.
Oh, your pen? I'm by you pen. Thanks for the text. Oh, you did?
So whom do you report to there?
Jeff Kerr.
Oh, so you report to Jeff?
Yeah. I work with Jeff.
Huh?
I work with Jeff mostly. I am in the lab so far.
Most of the time?
Yep.
Yeah, that's good. Yeah. He's a good guy.
He's